Good morning, happy Saturday, welcome to my talk. This is a talk about how we're going to build software understanding for a group of people I'll call 99% developers. I will say if you're at Strange Loop, you might be in the 1% of developers, but that's not why I crossed out observability, it's just crossed out for other reasons that'll become apparent as you proceed with listening to this talk. Okay, so this is about what I work on, but it's also it's about what I believe a lot more people should be working on. And I first came to work on this because over the last few years, I've talked to hundreds, if not thousands, of software teams, and I kept hearing the same thing over and over again. So I used to work on programming language design and type systems, static analysis, like a lot of the stuff people come to Strange Loop for. And I would go around to software teams and be like, hey, so like tell me about your the types you use and the tests you have. And they're like, Gene, what do you mean? And I'd be like, okay, maybe this is a fluke, on to the next team. And I noticed this over and over again, where people would kind of sheepishly tell me oh yeah, we know about testing, we've heard of types and we've heard of all this stuff, but at the end of the day, we have no clue what's going on with our systems until production. And the first few times I was like, they're pulling my leg, I don't, But then after a while, I was like, this is a pattern. No one's really willing to talk to, they're kind of embarrassed to tell me just how bad it is. But this seems to be true of every single team that I meet. And then the other thing was, these were really smart people that I was talking to, but they were telling me best practices are generally very, very hard for us. And so, I don't know how many of you here get to program Haskell for smart contracts and how many of you here are living in the real world, but but I feel most software teams that I encounter, it's not that they don't know the right way of doing things, because I feel a lot of tool developers or a lot of language designers are hey, I'm building the best language that ever existed, and when my language, hits GitHub, it's gonna fix all software problems because people just didn't have anything better. And what I realized was that's just not true. It's not true. And so this talk is about, how can we help people work with the systems that they have. And the reason I crossed out observability, there's a reason, there's drama. I'm trying to stir up some drama here. So please everyone tweet about this. Cool, so see, I keep crossing it out so that this is very dramatic. So I'm gonna start by talking about the breakdown of the software development lifecycle. So you might say, well, Gene, Waterfall died in the 80s, come on, get with the program. But I think that we all have notions of what dev tooling is and what software development is that I think we just need to throw out the window. I think, I don't know how many of you are in the I test and prod train, but I think even that needs to go a little bit further. So I'm just gonna make sure we're all on the same page of what the breakdown of the software development lifecycle means for all of us. I'm not gonna actually explain what observability is. I think it may be more apparent now because I crossed it out. But I'm gonna talk about what I call the observability gap that I noticed. So as I continued with my anthropological exploration of these developers that clearly I had no clue what they were really about, I realized that there's really a gap in tooling to help people understand what their systems are doing. And then, oh no, I forgot to cross one out. I'll talk about what it means to really help developers, and not just the most elite developers who have, the ops resources and the extra time and the weekend cycles to throw at this problem, how to help, regular developers who have lives and, things outside of work and don't want to spend their winter break learning observability. How do we help everybody understand what their software systems are doing? Because, types are not going to save the world. There's not, guys, really not. And to give you a little bit of background about why I think I especially really keep making this point is I previously, this was my life. So I was previously working as an assistant professor at Carnegie Mellon University. So for people who know, that's the altar, some people call it the altar of Bob Harper, but it's types, higher order types, even higher order types. But it was all about we're gonna prove every single last line of code correct in the world. And I bought into that for a long time until I was wait a minute, my code is calling into other code and that code's not correct, and then we're calling some APIs and those APIs aren't correct either. What are we gonna do about all this? And they'd be like, Gene, don't worry about it, it's gonna be okay. Oh, oops, I'm forgot to fully delete the last line. Sorry, there's a lot of deletion. Anyway, so I started working on my startup, Akita Software, after realizing just how much system behavior is not captured by what's going on at the language level, which, like, to many of you, like, working developers out there, you're probably like, that's very obvious, Gene, this is our reality. But I'm just saying, you know, I was in a cult for a long time, I got out of the cult, you know. I'm here now. Yeah, my last line is supposed to be, I discovered that, you know, there's all this stuff out there, and there's a really deep need for tooling that was an abstraction level beyond monitoring and observability. So, like, one of the points I like to make is, like, we're, like, sort of in the 1950s, 1960s point of monitoring and observability. We could be doing a lot better. And one reason I want to recruit all of you to the dark side with me is I think that you are a crowd that cares about abstraction, is super thoughtful about tooling. And, like, I don't know, let's not put all of our mind power on dev time and CI. Go tweet about this, it's very dramatic. Okay, so I'll start with talking about what the breakdown of the software development lifecycle means for you. So, like, I'll tell this story very much from my perspective. So here I was living in my cult cave, and I was like, yep, we're gonna prove every line of code correct in the entire world. And then I was like, oh no, there's a lot of lines of code out there. So that was like my first realization. So this is a pretty old graphic by now. It's not very clear, but if you want to see, I would look up, like, information is beautiful lines of code. You're not supposed to actually see the graphic. That was intentional, but, you know, it talks about how the original, like, operating systems were, like, I don't know, I'm gonna exaggerate, like 100 lines of code. And now, like, a car is like 100 million billion lines of code. And so you're just like, okay, you know, like the kind of goals we started with back in the day just, like, aren't cutting it anymore. And if you look at, like, any single one of these web apps, like, you know, like a single iOS app is now, like, many orders of magnitude bigger than the original operating system. And so that was when, you know, as a young grad student, I was like, I don't think this is gonna work, guys. Like, are you sure? And they're like, no, we were sure. So there's that. But then the other thing that really got me was, I was like, man, like, what about these microservices that keep getting more popular? Because, so, like, I'll get more into this, but from, like, a language and type analysis point of view, anytime you call out to the network, like, you subvert all of your guarantees, you have no guarantees. So I was very troubled by this, because at first I was like, there's a lot of languages now. Anytime you call to another language, like, how are you gonna handle that? And then I was like, oh no, microservices are the worst. There's no guarantees anymore. And then it got even worse. Like, this was, I was a grad student kind of in, like, the late 2000s, early 2010s, and it was really the time of the rise of APIs. So I was like, microservices may be okay. Like, someone can, like, decree everyone uses the same language, and you go and, like, prove all the lines of code correct or something across all the languages. Like, you can kind of get around that, but if you're calling an external API, like, that's across the network, you have no control over those people. Like, people are really hard. And so, like, that was really what convinced me it's not possible to get around all of this. Like, the network components are gonna be heterogeneous. Like, you cannot control what happens outside of your world. Software is just really, really different now. And again, like, maybe all of you were like, this was very obvious to us, Gene, like, this is just the world. But I hope this is at least useful from the perspective of this is why your language isn't gonna save you. And so, so I think this is what led me to believe software development has just changed. So you have the rise of APIs and SaaS, making it easier than ever to quickly add functionality to a system. What you really have is this ecosystem where you have components coming in and out. There's functionality you can't control. There's no high-level spec anymore. The implementation depends on how the components fit together. And this just, like, blows a lot of people's minds. I think especially because, when I was a freshman in college, I went to a lecture by this guy named Jerry Sussman. He wrote Structure and Interpretation of Computer Programs. And he said, people become programmers because they like to play God, because you have full control over your system. And so at the time I was like, oh yeah, it makes sense. Programs are like 10 lines long and you have a lot of control. But that's just not true anymore at all. And so, the observability people, and I'll get into that, will have you believe testing now happens in production, whether you embrace it or not. This is just a lot of, what you have to do. You're not doing this out of being irresponsible. You're not doing this because you don't know any better. It just does not make rational sense not to do that. Like, my team has unit tests, we have integration tests, but like, where does all of our stuff break? Production. Like, the testing does not really work. And then, even further, so a lot of the work I was doing was on like, how do we make authorization policies? How do we make those kind of policies? Like, how do we prove that to a spec? I saw a talk once that was like, hey, at like many major companies, who's allowed to see what? We don't decree that up front. We just, go through and document what our system actually does, and that's our rule. Because these systems are just way too complex. They've evolved way too much. They're the result of way too many people doing things. Like, no one really knows what's happening in these systems. For things as one might think is seemingly critical as, authorization. Who's allowed to see sensitive data? And so I think that probably, like, if you're working developers, you know this already, but I suspect you still subscribe to a philosophy of tooling that has not acknowledged this already to some degree. And so this is the reason I keep making this point. Like, I think most of our tooling has not come around to this point of view. So, wait, this was the wrong direction. Okay, cool. So to sum this up, if we go back to like our old original software development lifecycle, you start with planning, haha. Then there's analysis. Then you do some design, haha again. Then you build, and then you have this testing phase. This mythical testing phase, and then you like ship your shrink-wrapped CDs and floppy disks out to your users, and then they use it forever. And this is something that actually struck me with Doom creators talk yesterday, where I was like, man, like, how did they make sure everything was correct? I guess they had to, but man, like, software must have been a lot smaller back then. Like, no offense to them, but that was a thought running through my head. I was like, there's no way we can ensure no bugs these days. But, maybe that's just us. But, today, what software development looks like is you kind of build something. You see, does it really do the things that I think it does against all of the other APIs and things I'm using? Again, this is not if you're a Haskell developer working on smart contracts, you live in a different world. And then it's a lot of maintenance because you're maintaining your own code. If you have an app, if you have an API, you're providing a service, and that's in constant conversation with your users. That's in constant conversation with your runtime, with the other APIs you're using, your third-party integrations. And so it's just a whole heck of a lot of maintenance. And then I read a tweet the other day that said that the average tenure of a programmer is becoming something like 2 years. So I think a lot of tooling and a lot of best practice was created assuming that the original tool creator was going to be around for the duration of that tool. That's just not true anymore. And so, like, there's a lot of technical factors why this is the case, that everything's gotten blown up. There's a lot of human factors. Bless you. But it's simply, we live in a different world. But, I don't know about you, but I was taught that tooling served a specific purpose, and it took me a long time to come around to the fact that, wow, like, our tools should really be doing something else for us if this is the case. Bless you again. I was teaching university level programming for a while, and I was, we were still teaching them some of the old practices. We were like, debug with a debugger, not printf. But, in this new world, like, how many of you do primarily debugging with logs? You don't have to raise your hands, but you can raise your hands, Like, we are all doing printf debugging. And then, other stuff I taught was like, use a type checker and linter to help you so you're not doing, you catch preventable errors before production. These do not exist if you have APIs, third-party integrations, all of that. I think people are like, yeah, I'm using my, like, typed blah, 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 and I'm using all my blah, 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 and then I'm just calling all these third-party integrations. Like, okay. Don't you want to ask? Like, I'm glad that this part of your system is good, but, like, what about the other part of your system? And then, finally, something that I would teach is test on small examples before you do the whole thing. But I think that, if the norm is testing in production, we just don't have, we don't have the practices there yet. Like, like I think right now the state of the art is set up your logging, your printfs, like the best you can, so that when your big system spews out all the logs, you're like in a really good position to understand the whole thing. It's like not the best practice we taught at all. So I'd like to just point out that we need new software practices too. New tools, new software practices, go. Well, you can go at the end of the talk, I guess. And so like this is how I came to really believe in the general observability philosophy. So like, many of you have probably read or listened to what Charity Majors has to say, but a quote I really like from her is, once you deploy, you aren't testing code anymore, you're testing systems. Complex systems made up of users, code, environment, infrastructure, and a point in time. And I think that's the big thing, like everything else is changing around you. These systems have unpredictable interactions, lack of any sane ordering, and develop emergent properties which perpetually and eternally defy your ability to deterministically test. And so one analogy I like to make is that software is not a planned garden anymore. It's this rainforest. Like, you have these organisms, they're out of your control. It's beautiful, it's great, but you're playing more something like archaeologist or biologist than God anymore. And it's a different game. Okay, so if you want to know what general observability is, I'll let you look that up on the internet. Because I've crossed it out. But I'll quickly summarize. So people say the 3 pillars of observability are logs, metrics, and traces. And there's really a philosophy around like, set up your instrumentation and logging right so you can test in production better. So I will spend the rest of the next section like throwing this under the bus, out the window, whatever analogy you want to use, because I think that is not practical for the same reasons I think everything else is not practical. Okay, so something that I heard more specifically from developers when I talked to them was, we often don't know what endpoints we have or when something bad happens with one of the endpoints. And first I'd be like, well, this is your system, like how do you not know? But there are a variety of reasons, right? So they weren't the original creators of the system, like they're interacting with another service. There's just, they are responsible for a small part of their system and no one's had time to deprecate stuff. No one knows if people are still using some of the endpoints. And if this appeared before anyone thought to instrument it the right way, like if you don't know it's there, how can you instrument it? So this is a problem that I just kept hearing over and over. Like, we don't really have control over our system. And like, what I found was people would be like, well, at one point we tried to log and monitor everything, but then a lot of other stuff got built because we had deadlines. We had, we had some kind of like reorg. We had some people leave. There's just, there are a lot of human factors in why stuff is not perfectly logged, metriced, and traced. And so, I would be like, okay, what about all the tools you have? And a lot of the time people would be like, what tools? We don't have time. But the people with tools installed, those would be the kind of reasons they would give me. It's just like, we are smart people under constraints out of our control that things just can't happen, and it's not our fault. And I mean, I agreed with them. It was not their fault. And so another thing I noticed was that what people were telling me was sometimes it can turn, it feels like, managing logs can feel like, the old style of programming where you change some code and then you like turn a knob, like I need to like output this different log now. And so like people just simply didn't have time for that, because like here they were with programming languages that were, in the modern era, and they were still having to manually keep their logs and dashboards and everything else up to date with their very fast moving system. And so that, again, I was like, okay, this again makes a lot of sense to me. This is not good, but like I see why you're doing that. And then, like something, I had made this slide for DockerCon, so there's some Docker icons out there, but this is a graphic from the GitHub state of the Octoverse, like where do developers live? But, I feel like some people, when they think of developers, they think of, Silicon Valley or, Bell Labs back in the day still, like my Bell Labs folks out there. But, there are people out in the world just like picking up picking up languages, picking up things, it's not who like originally we thought of as like the developers people might be building for. And they're doing all kinds of stuff. So side tangent anecdote, the other day someone tweeted, "Why is WordPress so popular?" And I was like, WordPress is very configurable and you can do anything with it. Of course it's popular. And they were like, "Who are these developers using WordPress?" And I was like, what do you mean they're and they're like, "Are they like sysadmins?" I'm like, "No, like it's people using HTML. Have you not used WordPress before, bro?" But I think that a lot of people still think of like developers like a very back-end infra kind of thing in like somewhere in America, or I don't know, like I'm just spewing stereotypes now, but I don't think people realize how just like who out there is developing and where the centers of gravity are, and like a lot of them aren't as vocal on in the same internet forums that other people might be, and so one thing I've noticed is just like who's writing a lot of stuff and who's writing a lot of stuff in English really skews our perspective of what's out there. Something that like really helped me kind of realize what was going on was reading some of Scott Hanselman's stuff. So I don't know if you've come across his stuff, but he has a great post called "Dark Matter Developers: The Unseen 99%." I actually, if you're interested, I wrote an essay building for 99% developers that was very inspired by that. But he said, where are the dark matter developers? Probably getting work done. Maybe using ASP.NET 1.1 at a local municipality or small office, maybe working at a bottling plant in Mexico in VB6. Perhaps they're writing PHP calendar applications in a large chip manufacturer. So fun fact, my mother was one of these developers working outside Silicon Valley, working on a calendaring app, like, writing, I don't even know what she was writing in, but so I was very familiar with this. And for us, like, it was interesting because when I started talking about this, who showed up to like our very early alpha was all of these kinds of developers. And I'd never heard of them before. I'd never really understood, I was just like, it's very hard to understand your systems. We're going to make it better. And these are the kind of people who showed up. So when I read Scott Hanselman's post, I was like, oh, this is who's getting really left behind by monitoring and observability tools out there. So I haven't really gotten into what observability is, but I'll just give you my take on observability today, and then you can go read about it, I guess, if you want. But I think that there are great power tools for expert teams. So there's a lot, I would say the observability influencers out there are like, if you know what's going on and you have the ability to really be disciplined all the time, then you can get this great ability to understand what's going on. Like you can trace your P99 tail latency across all of your services. You can do all this other stuff. But what about everybody else who doesn't need to do that kind of optimization? Or you're trying to find what is my slowest endpoint, one endpoint, or is it 5 endpoints, or what are my endpoints? That's a much more basic set of questions that I think a lot of people have shown up to have. And if you know what you want to track and how you want to track it, you can easily understand. Well, you can understand what's going on with your system. But if you want information out of your system that you didn't anticipate, because these tools are so manual right now, it's harder. And so even experts have to be like, okay, I had this bug, I'm not gonna have this bug again. But imagine if you're not an expert in either the tool or the system, how are you ever supposed to know? And so this is the set of problems that I think is hard, is interesting, and a lot of people need to get solved. And so, to summarize, I think our conversations about software development often assume there's a planned garden. We assume tech stacks are homogeneous to some degree. A lot of tooling assumes this. How many of you have heard if you just use GraphQL, all of these problems will go away? We assume that tech stacks are fully out of our control. So I have come across so many teams, they're like, Gene, we're in the middle of the migration. By next quarter, all of our problems will be fixed because, we're just going to be fully on this thing. And I'm like, okay, I'll talk to you in 2 quarters, good luck, but I don't think this is gonna happen. I don't come across that many teams that have high confidence their migrations will complete in a quarter. But people, they're just like, oh yeah, we're gonna, what about this? We're gonna be fully on this in the next 5 years. No, I don't Sorry. There's also this implicit assumption that tech stacks don't change much over time. That goes back to the homogeneity. Because if you accept that tech stacks evolve, you accept that they're heterogeneous, because by the time you're done migrating your first thing, you'll be on to your next thing. Like, by the time some of these companies finish migrating to GraphQL, there's going to be something that none of us predicted that they need to migrate onto next. And so, if you're assuming that you're all going to have one thing, you're assuming that GraphQL is the thing for the rest of time, which is just simply not true. And then you're also assuming to some degree people who write the code are around to maintain it, like I said. And so all of these kind of need to go out the window. And so, what I think we need is to build tooling that can work as widely as possible across the components of a system, heterogeneous components. Make tooling as easy to install and configure as possible across the system. And so, like, one thing we encounter is a lot of teams are like, we don't have time to set up observability or monitoring right now, because they assume they're going to have to, at least upgrade libraries or yeah, like for us, I think we had 3 services at the time as a startup. Our most senior engineer spent a week dropping in Datadog's APM because he had to upgrade a library, which meant upgrading all of our other libraries, and he didn't originally write those libraries. And so I think by day 2, he was like, I've lost the will to live, like some kind of death emoji. But it's not easy. And then the big thing that I realized was we need to make tooling usable by people who inherited a mess of a system. And so now, hold on, let me check the time. Okay, cool. Now I'm gonna talk about what it means to build, what it means to us to build API observability for 99% developers. It's brought to my attention that observability itself is a very daunting term that people do not associate with 99% developers. So I've been running around and trying to cross this out. And I'd be really curious what you think is a better term, because I used to call it a general understanding of your software system, but that wasn't as catchy. So I talk to me, tell me your ideas. But for us, we set out with the challenge of how can we tell a developer as much as possible while asking as little of them as possible. This is an ongoing process. It is very hard. If it were easy, other people would have done it already, and we would have done it already. So what we're working on is how far can we get with no instrumentation. So if we ask the developer to provide no information, so no code changes, no annotations, no custom dashboards, how far can we get is the challenge we set out for ourselves. So the first thing we realized was, okay, we can kind of use passive traffic listening. So some of you may have heard of eBPF. I recently discovered via Twitter polls, eBPF is an incredibly unpopular term, even less popular than observability. And people really hate it. I'd be like, which term do you hate the most? And people would all vote for eBPF. Anyway, but we're essentially using this technology called eBPF, so it's Extended Berkeley Packet Filter. Yeah, to drop into a system and passively watch traffic. So what this means is people would install something that says, I give this agent permission to watch on these ports. We use this technology that doesn't sit in the data path. We watch on the ports, and then we do stuff with the traffic. So I will say this is not a novel approach in itself. There's a ton of startups, well, maybe not like a literal ton, but there's a lot of startups and there's a lot of companies. Like pretty much every monitoring company is developing some kind of eBPF approach because it is like the least invasive way to get into a system. But what we quickly learned, though, was we built this eBPF-based solution. We're like, all right, users, drop us in. And they were like, okay, you're showing me all of my traffic, and there's a lot of it. And so, what we heard was they were coming to us because they were like, we want it to be less overwhelmed, not more overwhelmed. Now you're just showing us more traffic. And then, they also told us when we were logging ourselves, we didn't have any logs, but at least we knew what they meant. And so... So they're like, okay, what do we do with this information? What are we supposed to pay attention to? So I guess 2 lessons from this. 1, do not be tricked. If someone says, we have eBPF, that might just mean they dump a bunch of information on you because this is what we used to do, and this is what I think a lot of other tools do. And it's actually very hard to do better than that. That's what we've been working on for the last 2 years. And the second lesson is just there's a reason. There's a reason people haven't solved this problem more. And so the second thing we were like, we can take this traffic and then we can do stuff with it. But then the question was like, what? So we started out taking the traffic and inferring basic paths. So like, for instance, like I don't know how many of you work with APIs, but you have like, /user0, /user1, /user2. Turns out a lot of tools actually make you group those manually yourself. So the first thing we did, which we thought was just like necessary, was we inferred those paths. We were like, well, we need that to infer other things like types on the paths and changes on the paths. And so like my background is like compilers and languages. Like a couple of my early team members, that was their background. So we're like, we'll just infer stuff. And so first we're like, yeah, we're gonna go to town with our programming languages background. We're gonna infer everything. And then we're like, okay, one, this traffic is super messy. And two, people don't actually care. Like, like I said, like types aren't gonna save you. Like first we're like, we give you types. And people are like, yeah. And then like when we actually saw what they use, they're like, we like endpoints. And we're like, oh, okay. And so, yeah, so we've spent a lot of time by this point doing automatic traffic modeling. We started out thinking it was the fancier stuff like types, changes. And they're like, okay, first of all, like you always over-infer stuff. But secondly, like basic endpoints are really good for us. So I'm happy to talk more about this, but this is, I think some like more general tooling here is where I would like to see a lot of other people like spend their time demanding tools and spend their time building tools. I think this is really the hard part. So just really quickly about what we're building, especially if you want to try us out, give us feedback. We're in beta. You can sign up on our website, akitasoftware.com. But what we do is we passively watch traffic to build what we call API maps in near real time. So we use packet capture. We automatically infer endpoint structure. And then our recommended way of running us is staging in prod. Another whole talk is like we originally thought we could run in tester staging. Like that was just... Again, went against all the things that I said. I'm like, well, people are moving to prod, but we can move them back. No, that just didn't happen. Again, a drama. So I'm about out of time, so I'll just wrap up with the few points I want you to take away from the talk, if you take away any points at all. Modern software development has blown up software development practices as we know it. We should be looking for new ones, and we should be demanding that people break out of the current state. In this new world, we need to supplement existing monitoring and observability solutions with something higher level and more developer friendly. So there's 2 points here, shift right and shift right better. And then the other thing is, for software understanding, we need drop-in tools to help people who are not necessarily experts in the technology or the tool. So one reason I crossed out observability is it's still like, do the right thing, read the manual, and you'll be okay. People should not have to do the right thing. They shouldn't, or not, well, to some extent. People do not need to do the right thing. Everyone should do the wrong thing. No one reads, and things should still happen correctly. But yeah, my bigger point is, look, we can't expect people to do the right thing if there's so much churn, if software systems are so complex, and if software is just this completely different beast than it did before. And so, yeah, you can find me on Twitter. You can find Akita on Twitter. Like I said, I would love to have you try our beta and give feedback on it. Like, this is a very traffic-dependent thing, so the more people who give us their traffic early, the better the tool is. And then I have a small number of Akita stickers that look like this guy here. So if you find me after the talk, I will give you one. But yeah, thanks for being a great audience. Oh, yeah, this is a good question. So there's a question about how do we process and make inferences about encrypted traffic. This is very hard. We were recommending people use a proxy for a while. So I will say there's like a surprising amount of people who don't have encrypted traffic. So we've been punting on that problem for a long time. But we always sort of maintain this like side experimentation. Some people have had success using us with a proxy, although like so few people did it. We started deprecating that path because we're like, we don't know what weird things are going to happen. I think the thing we're going to end up doing is building a proxy into our agent. Because I think that like with encrypted traffic, we tried for a while to basically parse like TLS metadata, but that was super unstable. Like you can't get all the information you want from TLS metadata. So I think for encrypted traffic, you either have to co-locate with where your certificates are, or like before like your TLS termination, you have to like work around that, or like we just have to proxy that, which then puts us in the data path, which like we really didn't want to do. But yeah, encryption is super hard. But what we also found is like a lot of people just don't encrypt inside their systems. So yeah. Yeah, that's a great question. So the question is, how similar or different is this problem space from network intrusion detection? And so I have a blog post from like either last week or the week before where I talked about how like security people have been doing this for a long time, watching traffic and doing stuff with it. And I think like, we actually started out in the security space. I think there's a ton to learn from intrusion detection. Because I feel like it was only like programming people that were like, we can define everything, and security people have been in this world for much longer. Like, we accept we have no control, we have to be from the outside, black box, all of that. And so I think a lot of the techniques in that space are good. I think where we can enhance it is like more modeling to bring, because I think before it's just like, you have like rules, like this is an intrusion, this is not an intrusion. Can we actually model what's going on to a higher degree is the question I would like to pose. I think that would have tremendous value. Yeah, no, that's a great question. So the question is, what about service mesh? And like, if everything lives within a single service mesh, does that give us some of the standardization we need across heterogeneous components? I think that's a great question. That's one I thought about for a long time. I think like we actually I spent a long time deciding like, do we just integrate with a service mesh? What I found was that there's not a lot of standardization among your service meshes right now. Like maybe it'll happen, maybe it won't. My suspicion, and like I will bet $5 to one person on that, so it's not a very like high conviction suspicion, but just like there hasn't really been good standardization around programming languages, I think you're gonna have the same problem. Like different people have different, like they're in different communities, they come from different cultures, and they have different needs, so they're gonna pick up different service meshes, and then like those needs are gonna evolve over time. So I think it's like I think there may be a fundamental reason why there hasn't been standardization around service mesh yet, and like not a it just hasn't happened yet reason. But yeah, that's something I've thought about a lot. That's a great question. Yep. That's a really good question. So for us, like, it doesn't. There's like, okay, so like, don't push me on the actual answer to this question because I don't know why. But somehow we work on Windows. But not all Windows. Like, so I don't, like, you would have to ask someone on my team why this is, but I think, like, I was kind of trying to figure this out, but I never got to the bottom of it. Like, we somehow work on some Windows. I will also say we're not using any of the fancy probes. So we're basically using, like, the BPF subset of eBPF. A lot of the E stuff is like, we probe there and we do all this, like, fancy Linux stuff with system calls. Like, we don't do any of that. So I suspect that's a big part of the reason. Like, we're just sitting and doing passive traffic watching. Yeah, hello. Yeah, no, that's a great question. So the question is like, what's the role of types and who is it for? And I think that, one of my strong views is that like every tool has an audience. And I think if you're building like a space shuttle, you should definitely verify that code. If you're building like car firmware or something like that, you should definitely probably verify that code. But I think that for me, my interest was like, what about all the developers out there building more and more web apps? And like, I don't know how many of you had like weirdo issues trying to get like your COVID vaccine scheduled, or like trying to like get your insurance to approve something. Or recently, my husband couldn't get on a plane to Canada because there was a website bug that wouldn't let him say that he checked in, and he literally had to get on the next plane. Like, like I think we're like, okay, like only Facebook and Google need to work. But that's just not true. Like, your entire life runs on other websites, and most of these are web apps written by like probably people doing WordPress, and so like I am very interested in like how can we help like all the other developers out there, and I think that people doing smart contracts probably should be using types, but do I care about the tools for these people? No. Well, on some level, you care about all people in the world, but like, you can only have so much care. Yes. Yeah, that's a really good question. So the question is that how far back do you consider the 99%? And the answer is I hope someone considers the whole 99%. But one of my team members was like, Gene, I think we're considering the top 15% right now. And I was like, yeah, because we don't have the time to build all those other integrations. We're too small. And so like, yeah, this is something we found too. Like for a while, we were trying to support like every deployment and we were just dying. Like people would be like, I'm trying to run you on this like random thing, but I couldn't do this and I have to do this. And we're just like, oh my God, like we don't have time to do that. And so I think that there's, I don't know, I guess first you go to the 5%, and then you go to the 10%. Although I will say like, for us, we found like the developers who have very little tooling accessible to them right now has been a really good target for us because they don't require us to be as mature to start being useful. And so I think for every tool, there's kind of a different space. I'm gonna check the time really quickly because I think I'm probably, yeah, I think we're starting to get overtime, so thank you. This is a great set of questions. Again, great audience, guys. And I'll be around for a few minutes if you have more questions. Thank you.